Okay, in this video I'm going to continue on with exercise 4B of the book Fundamental Applied Mathematics. We're on page number 106 and the question is number 25. So the question reads that a ship which can sail at 10 meters per second in still water has to go from A to B. And we're told the displacement A to B is 195 meters. The current flows at 5I hat minus 6J hat like so. We're told that the ship wants to go from A to B, so of course its actual velocity vector, the velocity of the ship, is in an easterly direction. So if you were a helicopter above the ship, you would see it move east. Next we're told that we want to find the time taken to complete the whole journey. So what we need to do now is find out the velocity vector, either VSW or VWS. The question is, which are we given? Well, of course, the second letter here of WS or SW corresponds to the object which is in a stationary frame of reference. And we're told it can sail at 10 meters per second in still water or stationary water, which means we have VSW. So the next thing we need to do is work out which direction VSW is going. Where is the ship aiming in order to go actually east? And the question is, the answer is it must be going in this direction, because we must counteract the j hat component of your water vector, of course. So we're going to call this angle here theta. All right. So next thing we need to do is just resolve that vector. It's going to be 10 times the cos of theta I plus 10 times the sine of theta j. So we know that VSW is equal to VS minus VW. Alright, so that's just going to be 10 times the cos of theta I hat plus 10 times the sine of theta j hat is equal to, I'm going to call the velocity of the ship x, so it's going to be x I hat plus 0 j hat, and we need to take away from that 5 I hat minus 6 j hat. Now of course all the i's equal and all the j's equal, so we're going to get that 10 times the sine of theta is equal to 0 plus 6. Alright, now by the way, just to point something out here, we're just getting rid of the j hat component. So the j hat component of the VSW, the velocity of the ship relative to the water, should be equal in magnitude to the velocity of the water. Alright, which is exactly what we're after getting. So if you just inverse sine that, you're going to get theta at 36.8 degrees. And how does that help us? Well, it helps us because we know that 10 times the cosine of theta is equal to x or minus 5. Alright? So let's just plug that into our calculator. So the cos of 36.8 multiplied by 10 plus 5. So you're going to x is equal to 13 units. So what we actually just found out was that the velocity of the ship is equal to 13 I hat plus 0 j hat. And we're required to go from A to B, which is in an I hat unit vector direction, and we have an I hat unit vector velocity. So we just divide 195 by 13 to get, I think it's 15, but I'll do it all the same. So yeah, so 15 seconds. So that took 15 seconds. So the outward journey AB took 15 seconds. And now we have to get the return journey. Now, I'll tell you, we don't have to start from scratch, because in this case, we'll just get rid of VSW. In this case, the velocity of the ship is actually going in a westerly direction. Alright? That's the velocity of the ship. So this time, the velocity of the ship relative to the water must be going in a positive j, negative I direction. So it's negative I, positive j. See, the only thing which we have to change is that we have to put a negative sign in front of our cosine here. Alright? Now, by the way, I'll let you get you're going to find out, of course, that theta is going to be the same. However, if you left it at negative 6 over 10, you would actually get that angle there, alpha. So just be careful that you get the angle theta, the smallest of the angles. Okay? So you're just going to get, for the I hat component, negative 10 times the cos of 36.8 is equal to x minus 5. Alright? X minus 5, so it's going to be 10 times the cos of 36.8. 36.8 times the cos of the angle multiplied by 10 is equal to, we'll say, negative 8 plus 5 is equal to x. X is equal to negative 3. So its magnitude, of course, is 3 units in the negative I direction. That's what the negative sign counts for. So therefore x, of course, is, or not x, the velocity of the ship is equal to negative 3 I hat plus 0 j hat. So we just divide 195 by 3, or 3, and we're going to get 65 seconds. So the time total, t total, is equal to 15 plus 65 is equal to 80 seconds, which is correct. Alright, so the second thing is we're told a faster ship can go from A to B in 13 seconds. How long will it take to go from B to A? So what do we do here? Alright, first of all, we're talking about A to B, so we can get rid of this negative sign again, okay? We're back to our original situation. We're told we can go from A to B in 13 seconds. So it's got 195 meters to go. It does it at x meters per second and does it in 13 seconds. Therefore we can find that the time, I think it's 15 again, so divide it by 13, and we're going to get x is equal to 15 meters per second. Alright, x is equal to 15 meters per second. How does that help us? Do we need to find out the angle theta? And the answer is we don't. Because if we know that x is equal to 15 I hat plus 0 j hat, we know, of course, that when it changes direction and goes from B to A, that just becomes a negative number. Alright? We'll say the 10 cos theta becomes a negative number. Alright? So, if we just look at our original situation first, we have that 10 times the cos of theta plus 5 is equal to 15. Therefore, or not 10 times, excuse me, x times. We don't know what this is, so I'm going to call it y, because of course its speed has changed. Alright? So we'll just say y cos theta is equal to 10. Y cos theta is equal to 10. So this here, this is a y, excuse me, this is a y. So what that means, of course, we know that when it goes from B to A, this just becomes a negative number. So it becomes negative 10 instead of positive 10. So now what we have going from B to A is that negative 10 plus 5 is equal to x. Therefore x is equal to 5 meters per second. So we have 195 meters to cover in 5 meters per second, and we get 39 seconds, which is correct. Alright, I hope I didn't rush that second part there. It should be pretty straightforward. It's the exact same procedure. Once we found out what this magnitude is here, or the magnitude of this, well, its direction was as of part 1. So thanks for watching. Please pass it on to your friends and subscribe to my channel.